Water matrix, again, very important. What you see here is a graph simulated by our model of the bromate formation in a time series of 40 days. You see a lot of dynamics. So you have higher peaks, you have lower values of bromate. And if we look at, for example, the input parameter ammonia that we also take into account in our model, we can see there's a direct link. So when your bromate levels are dropping, this is clearly caused by an increase in the ammonia levels. And we see actually the opposite when you have very low ammonia levels, which can happen after your aeration is switched on to its maximum level. Then you can have an increase in your bromate formation. So you clearly see that the ammonia is a very important parameter in controlling bromate, and that dynamics are also very important once you are operating an ozonation plant. And yeah, with the model, we can predict these dynamic variations in your micropollutant removal and your bromate formation, and we can see what is causing this. And that's how we can help you in smartly controlling your ozonation plant. We will go to Italy again for a demo. So Giacomo will show you some more of this.
Yes, welcome back. Let's directly go to my screen and have a look at this data. So these are like samples. Imagine these are your samples. And you took samples and measured bromate at different times. So this is a period of 7 days or something. So, but the question is, what happens in between these days? Are we missing peaks? Are this like a composite samples? Are these grab samples? So it's difficult to say because in the meanwhile, between one point and another, all kinds of dynamics in the plant will go on. So the influent has its dynamics, as we have seen. We have the flow changing. We have UV absorbance changing, so the load of organics is changing in time, and also the ammonia, as we have seen, is changing. So as you can see here, there is a peak in UV absorbance, which is brought by the washout of the sewer. So and right after that, there is a dip in ammonia. As well, so, due to the upstream biological plant, which is probably over aerating as a response to the ammonia controller, and also at this other peak, ammonia is lacking. So what is happening actually in between this bromate measurements, offline measurements, and we can pass the model through that. We can simulate these days and see what happens in the dynamics. This huge peak and this one were generated by specifically low ammonia levels at certain moments, as we were saying, as a result of the dynamics of the influent, so the concentrations that are incoming to the plant. So there is an initial washout of the sewer, but then there is also a dilution effect brought by the rain event. And then also the operational settings of the upstream biological plant, which is over aerating and removing more ammonia than necessary, which is resulting in these peaks. Now, if we run the same simulation with, let's say, a dosage of peroxide, then we can sensibly lower the bromate formed, and we can monitor this throughout the installation. There are moments in which this the peroxide dosage is more effective due to specific conditions of the influent composition, and other moments in which it would not even be necessary to dose peroxide, and then we can even save chemicals and operational costs. But on the other hand, we can also, as has been speaking about the ammonia, we can also increase have more fancy controllers and try to control bromate, optimizing the aeration at the upstream plant. So making sure there is a minimum ammonia concentration coming out, that we are not exceeding, of course, the effluent limits, but we can still have a sufficient action of ammonia on hyperbromous acid. And that will result, as you can see from this purple line, in a shaving off of the peaks that I was talking about before. So in these cases, specifically at 4.5 days and 5.7 days, you can see that the peaks are shaved off just because we optimized the upstream wastewater treatment plant controller to ensure there was just enough ammonia to avoid the peak bromate formation. Yeah, with this, I thank you. And then I give back the screen to the presentation.
All right. Thanks, Giacomo, for this interesting demo. All right, so yeah, Giacomo clearly indicated the power of these dynamic simulations, and this can help you in understanding your system even better and the impacts of these variations on bromate formation and micropollutant removal. The previous graph I showed you was from a plant that was not built yet. We also applied our Amazon model to an existing ozonation plant on a demo scale. And here you see 4 years of data. So a lot of bromate measurements measured at the effluent of the ozonation. And we modeled this 4-year data. And I wanted to show you this graph just to show you the power of a digital twin. So in orange, there should appear a beautiful graph. So yeah, you can see that the model really captures this dynamic data and predicts the bromate formation very well. And we are now actually building more and more of these digital twins of full-scale installations where we are going to predict the micropollutant removal and bromate formation in real time. So measure in real time on the influence side, basic data, and the model will predict the bromate formation and the micropollutant removal in real time, so that operators can use this information to smartly control the system and have better performance.